Today we'll be testing the horn circuit on this 2000 iron drive motor car. Alright, so before we do any testing on the circuit, we need to verify that our horn is working or not working. Alright, pressing the horn button, our horn is not giving off any sound. Alright, so our horn is not working. So we don't know where within the circuit that the problem lies. Right? So we're going to start off by checking at the most convenient area. Right? Check the horn circuit at the fuse box here. If you could come over and look closely at the fuse box, here we have a horn relay, right? And there's also a horn fuse, which is a 10 amp fuse. This is our horn relay here, and our 10 amp horn fuse right here. So removing the fuse box, right? And if you look on the fuse box, right? So this is our horn relay right here, based on the diagram on our fuse box cover, right? And this fuse right here, this 10 amp fuse right here, right, is our horn fuse, right? Now we are going to check the horn circuit fuse to see if it is blown, yes or no. So to do that, we'll use our test light. Alright, so we're going to connect the test light to battery negative or any ground point on the motor vehicle. Alright, so the best place to connect it is at the battery negative. Alright, connect the test light to battery negative, verify that your test light is actually working by putting it on battery positive, test light lights. So now we can go ahead and test the on circuit fuse. Alright, so this 10 amp fuse here. So on a proper fuse, right, the test light should light up on both sides of the fuse. So as you can see, this fuse here is good, right? So now we're going to check the horn fuse itself now. So they can see there we have lighting, right? You have the test light, and over on this end, right, there's no light. So what that confirms for us is that the fuse is blown, right? So now we're going to remove that fuse. So we're going to use our fuse puller, right, to remove that fuse. So our fuse puller is over here, right? So this is the fuse puller, right? So we're going to use it to remove, right, this 10 amp fuse, right? So we're going to get a replacement fuse, a 10 amp replacement fuse, right? We're going to insert it, right? And we're going to verify that this is actually a good fuse, right? So we should have light on that side of the fuse and on that side of the fuse, as you can see. So our fuse is now good, right? So this is the fuse that was inside the circuit. You can see close up that the fuse is actually blown, right? So that's a bad fuse, right? So now we're going to check the relay, right? See if the relay is getting a proper power feed, right, to it. Right? So we're going to remove the relay, right? So we're going to remove the relay. So let's pull it out with your hand, right? So now we're going to use our test light, right? So if you should look down in here, as you can see 4 terminals here in our fuse box for our fuse rather, right? So we have 4 pins on this relay, and we have 4 terminals here for our relay in the fuse box. So on 2 of these terminals, right, there should be a constant voltage on 2 of these pins here. So we're just going to use our test light to probe the pins, right? There's nothing there, and there's a power feed right there, which is okay, right? There's a power feed right here on this pin, right, which is okay. So what this confirms for us is that our relay, right, is actually getting a power feed, right, on both the control side and on the load side. But that doesn't necessarily mean that our relay is good, right? We are also going to use our multimeter, right? Our multimeter to check the voltage supply, right? To the pins here, the relay pins, right, in the fuse box here, fuse box. Because with the test light only confirms for us that we're getting a voltage supply, but it doesn't tell us how much voltage is actually getting there, right? So now we're going to set the multimeter to measure DC voltage. So we're going to set it on the 20 volts range because our battery is approximately 12.6 volts. So we set the dial over here to the 12 to a 20 volt DC range, right? So we don't want it on the AC voltage because our battery does not produce AC voltage, it produces DC voltage, right? So we're going to get our multimeter leads. You can see our multimeter has two leads, a black one, and a red one, right? So the black one always, right, should go into your common slot. So insert the common, right, lead into the common slot. Since we're measuring for voltage, right, we're going to insert it into the voltage / ohm slot right here, right? So follow me over to the fuse box now, right? So we are going to connect the meter. When we're measuring for voltage, our meter must be connected in parallel with the circuit. So we're going to place our black lead to battery negative, right? And we're going to use the red lead here to probe the pins that we had used our test light to probe, right? And we should be seeing 12 volts, right? Which is good. Anything less than 12 volts on these pins will indicate that there is a high resistance within the circuit, right? So they can see here, we are reading 12 volts. Our watch is a little bit discharged, right? 12.3 volts, right? That's good right there. And we're going to probe the other pin, right? 12.3 volts, which is also okay, right? So what does this confirm for us is that we have proper voltage supply to our relay terminals here in the fuse box, right? So the other test that we are going to carry out on the relay is a ohm, right? Or a resistance check on the relay. You should come in closer and look at this relay, right? This is a 4-pin relay, right? As you can see, we have 2 small pins, we have 2 large pins, right? The small pins, if you look closely, they are numbered, right? So this is 85, right? And this is 86. So pin 86 and 85, this is the control side of the relay, right? And pin 30 and pin 87, this is the load side of the relay, right? So this is when the relay is energized, right? So these 2 pins will send voltage to our horn down here, right? So the resistance check that we're going to make the resistance check on the control side or the coil side of our relay, right? So now we're going to set our multimeter, right, to measure resistance, right? So we're going to put it on the 200 ohm, right, and scale right there. So on a typical relay, right, as a general rule of thumb, on the control side or the coil side, pin 85 and 86, you should get a reading of between 50 to 120 ohms, right? And if you look at the multimeter here, we're getting a reading of 99.7 ohms, which is telling us that our relay is actually within specification. All right. So now, with the relay, this relay that I have in my hand now, it is de-energized, meaning that the switch for pin 30 and 87 is not activated. With the switch not activated, right, and you measure the resistance on these 2 pins, the 2 larger pins, you should get an infinite resistance reading. If you look at the multimeter, right, without getting any reading there, infinite reading, right, so this is telling us that this side of the relay is actually good, right? So now we're going to insert back our relay, right? Look at it properly. Insert back our relay, and so these 2 terminals correspond with these 2 terminals here, and this one corresponds with our terminal. All right. So now we're going to insert our relay, right? So now we want to confirm that our relay is actually clicking or actually switching. So we are going to depress the horn button, right? And we should hear a click coming from our relay. So press the horn button now, right? You hear a clicking sound telling us that our relay, horn relay, right, is actually clicking, right? Actually switching. So now, a relay that is switching, it does not necessarily means that it is actually sending voltage to our horn. Yet again, our horn is still not working. Even though our fuse has been changed, our relay checks out fine. It could be that you had some wiring problem between the relay to the horn. So coming a little bit closer, right? The horn right here, you're seeing a black wire and a brown wire here and a black wire here. So this is the positive feed, right? This is the positive feed for your horn, and this is the negative feed. Again, we are going to check the voltage supply there. Alright, so we're going to set our multimeter to measure voltage. Our leads are in the voltage slot and the black lead in the common slot right here. Alright, so we're going to place the black lead on battery negative right here, ensure that we have a good connection. Right? We're going to probe, right? We're going to probe, yeah, well, you could unplug it if you so desire, right? And we're going to probe this terminal here. But as you can see, right, as you can see, our horn button is a little bit defective. We shouldn't have a reading here right now until the horn button is depressed. I'm going to show you what's going on. Clark, come on, press the button for me. Let it go. Release. Press again. You're not pressing it now. Alright, so as the horn button is being depressed, press it again, Clark. We're getting a press and hold. We're getting a 12-volt supply, right, on our feed wire here to the horn. So as it's simply telling us that the wire from this wire to the relay is intact. It's good, right? So now we are going to measure or test our ground wire, right? Our ground wire could be defective wire, our horn is not functioning. Alright, so we're going to unplug our ground wire, right? We're going to move, right, our black lead and place it on this terminal here, make a good connection there. We're going to make a connection here, right? And we should see a 12 volts supply right there on our ground wire, a 12 volts reading on our ground wire there. When the connection is made between battery positive, it's telling us that our ground wire is good, right? So that is simply telling us that our horn here is defective, right? So we're going to confirm that our horn is defective by doing a continuity check on our horn. So again, we're going to switch the multimeter to measure continuity, right? So the scale, right, the dial is on this horn symbol here, or speaker symbol rather. If you touch two leads, here the meter beeping, right, telling us our leads have continuity. Right, so we're going to measure. So if the horn is good, when we touch this terminal here with this, right, and this terminal here with our multimeter, should have a beep. There is no beep coming from our horn. Right, here we have our replacement or spare horn. Right, we're going to perform the same continuity check on our horn. Right, replacement horn. Right, and we have some resistance reading there. Right, as you can see, this horn is good. Alright, we're going to confirm that for you. Alright, so we're going to connect it to our circuit here. I'm going to have my assistant Clark depress the horn button for us. As you can hear, the horn is functioning. Alright, so the last test that I will demonstrate for you now is a current flow. Alright, testing the current flow through this horn circuit here. Alright, so we can either make when we're going to test for current flow, we need to make a connection in series with the circuit, right? Series. So we can make the connection here at the horn, or we can make it here at the fuse box, right? Whichever is easier for you, right? So I will show you both ways, right? But first, we need to set the multimeter to measure current. Right, so they can see our multimeter is now set up to measure ohms or voltage. So we need to remove the red lead and put it in this slot right here, that 10 amp slot right here, and switch our dial here over to the 10 amp slot right. And now our meter is now set up, right, to measure current flow through the horn circuit. Right? So I'm going to show you the connection of the horn itself. So we're going to connect the meter in series with the circuit. Right? So this is how we do that connection here. So you can unplug either wire, this wire, right, or this wire. Right? So I'm going to unplug this wire here for ease. Right? Make a connection there. Right? And I'm going to connect my other multimeter lead to this terminal here. So now my meter is in series with the circuit. Now, as you can see on my meter, there's no reading on my meter. The reason why there's no reading on my meter, it is because that the horn is not activated, there is no current flow. So now I'll have my assistant to press the horn.
Yo.
Press the horn button for me. Alright, and we should go again. Hold on, I've lost connections here. Alright, you press it again for me. And as we can see, we have a reading of 2.5 amps thereabout. So I'm going to show you the other method and the other connections that we can actually take. Right. So again, we can do the average reading here, right, at the fuse box, right. So we can locate that 10 amp fuse again, right here, and remove it. Remove that 10 amp fuse, right. Now we're going to connect our meter in series with the circuit. So as you can look, if the camera can pick it up, right, down inside the fuse box here, these two terminals. So we're going to connect the meter in series, right. And again, I will have my assistant again depress the horn button and observe the reading on the meter. Press and hold. As you can see, we have a reading of 2.6 thereabout. And that concludes the presentation of how to test the horn circuit.